This podcast is brought to you by the Senior Techie, a source of information for seniors and others about technology.
It's really great to be here.
You know, I have to be honest with you right out of the gate. Usually, when we sit down to talk about medical topics, and especially when we get near the brain, my stomach tightens a little bit. Specifically when we get near the A word, Alzheimer's, or dementia in general, the mood in the room usually just, it hits the floor. It feels like we are bracing ourselves for a tragedy.
That is the historic norm, absolutely. For 40, maybe 50 years, the narrative around dementia has been one of decline, of loss, and a sort of helpless watching and waiting.
Yes.
It has been a scary topic. You get a diagnosis or you worry about a diagnosis, and the prevailing feeling is that there's nothing to be done.
Exactly. It's been completely defined by fear. But today feels different. I've been reading through this massive report from the Senior Techie, and I'm not seeing the usual gloom. I'm seeing something that looks a lot like a victory lap.
That is a perfect way to describe it. We are in a completely different landscape than we were even 3 or 4 years ago. It's a paradigm shift.
A huge one.
The Senior Techie has gathered comprehensive research on advances occurring in 2025 and beyond, and the headline here isn't about coping with the inevitable. It is about changing the game entirely.
And I want to speak directly to our listeners right now, especially if you are over 55 or if you are caring for someone who is. You have probably spent years seeing news stories that promise a cure that never arrives.
Oh, absolutely. The headline fatigue is real.
You see a story on Tuesday saying coffee prevents dementia and a headline on Thursday saying it causes it. You get cynical. You have to.
Rightfully so.
But what we're discussing today isn't theoretical, maybe someday science. This isn't about mice in a lab.
Yeah.
This is happening now.
Correct. We are seeing a fundamental shift from an era of watching and waiting to an era of detecting and treating. And the tools we have to do that are, well, they're surprisingly hopeful.
So here is our mission for this podcast. We are going to unpack the advances in detection, which are way easier than they used to be, the new drugs that are actually slowing the clock, and the lifestyle tweaks that act like medicine.
And we're going to do it all based on the data. According to the Senior Techie, the convergence of better tests, better drugs, and better delivery systems means we can finally offer a roadmap to keeping brains sharper for longer.
Let's dive right into the first big change. And honestly, this one brings such a sigh of relief to anyone who has ever been to a neurologist. We have to talk about diagnosis.
Right. Historically, this has been a major bottleneck, a huge one.
Bottleneck is a very polite way of putting it. I'd call it a nightmare. If you were worried about your memory a few years ago, what did you have to do?
Well, the options were not great.
No. You had to go get a PET scan, which is expensive and often not covered by insurance, or, and this is the one that gets me, you had to get a spinal tap.
The lumbar puncture, yes. They insert a needle into the lower back to collect cerebrospinal fluid. It is invasive, it is uncomfortable, and quite frankly, many seniors simply said, no thank you.
I don't blame them one bit.
They avoided getting a diagnosis because the test itself was so daunting. Who wants to go through that?
Exactly. But the Senior Techie says those days are effectively over. We have entered the era of the blood test revolution. Now walk me through this. How do you find a brain disease in someone's arm? I thought the brain was locked away behind a fortress.
The blood-brain barrier. It is a fortress.
Right.
But turns out the fortress is, well, it's a little leaky.
Leaky.
Just a tiny bit. When proteins like amyloid and tau accumulate in the brain, minute amounts of them, or fragments of them, leak out into the bloodstream. The problem was, for decades, the amounts were so small, our technology just couldn't see them.
Too small to detect.
It was like trying to find a specific grain of sand in a swimming pool. The signal was lost in the noise.
But the tech caught up.
The tech caught up in a big way. The Senior Techie highlights a specific breakthrough that was FDA cleared in May 2025. It is a plasma test looking for a biomarker called pTau-217.
pTau-217. It sounds like a license plate, but it's actually a protein in the blood, right?
Exactly. It stands for phosphorylated tau-217. And what is fascinating is that this simple blood draw, just like getting your cholesterol checked, can identify Alzheimer's pathology with incredible precision.
Okay, let's talk numbers.
Yeah.
Because that's what matters. How accurate are we talking? If I'm getting a blood test for something this serious, I want to know it's right.
The accuracy is stunning. The Senior Techie reports that this test achieves between 85 and 91% accuracy.
Wow.
That is comparable to the invasive spinal taps and expensive scans we used to rely on. So you're getting the same quality of information, or very close to it, from a simple needle stick.
That is huge. 85 to 91%. That removes the barrier. It removes the fear of the test itself.
It does, and I want to add a specific detail for our audience because the senior techie breaks this down by age group. There is a slight nuance for the older demographic.
Okay, let's unpack that. If I'm over 80, is it still accurate? That's what our listeners want to know.
It is. For those age 80 and above, the accuracy is around 83%. For younger groups, it is up at 91%. Still very, very strong.
So why the dip? Why is it a little harder to read an 80-year-old's blood?
It is likely due to what scientists call biological noise. As we age, we accumulate other comorbidities, kidney issues, chronic inflammation, other proteins just floating around from other conditions.
So there's more static on the line.
Exactly.
Right.
The signal-to-noise ratio gets a little worse. But even at 83% from a simple needle stick, that is a robust clinical tool. It completely removes the barrier to entry.
So step one is just knowing, do I have the markers for this disease? But the senior techie found something else that I think is even cooler. It's not just about a yes or no anymore.
No, not at all.
It's about knowing where you are in the process.
This is where it gets really sophisticated. We are moving from detection to staging. The report discusses a second biomarker called MTBR243.
Another complicated name. They need better marketing people for these things.
They really do. But think of it this way. The p-tau217 test we just discussed is like a check engine light on your dashboard. It turns on and says, hey, there's a problem under the hood.
Okay. On or off?
Yeah.
Trouble or no trouble?
Yeah.
Simple.
Right. But MTBR243 is like the GPS that tells you exactly where you are on the journey. It doesn't just say if you have the pathology. It tracks where you are on the disease continuum.
What does it track exactly?
It correlates strongly with how many tau tangles are actually spreading through the brain tissue. It's a measure of the disease burden.
And tangles are the bad guys here. They're the real problem.
They are the hallmarks of progression. Amyloid plaques are sort of the match that starts the fire, but tau tangles are the flames that burn the house down. The more tangles, generally, the more cognitive issues a person has.
So one test is the yes-no switch, and the other is the volume dial.
That's a perfect analogy. The senior techie notes that this biomarker, the MTBR-tau243, correlates strongly with cognitive performance. So by using these two blood tests together, a doctor can say, okay, you have the signs of Alzheimer's and you are currently at this specific stage.
Which is incredibly important because, as we're going to find out later, the treatments we have now depend heavily on catching things at the right time.
Precisely. It allows for staging. Just like we stage cancer, stage 1, stage 2, stage 3, to know how aggressively to treat it, we can now stage Alzheimer's through blood work.
It means faster answers, significantly less pain for the patient, and a tailored treatment plan from day one.
It really changes the conversation from, I'm worried about my memory, but I don't want a spinal tap, so I'll just ignore it, to, I'll just get a blood draw and know for sure.
And that shift in mindset is crucial because it opens the door to the therapies we're about to discuss. You can't treat what you haven't diagnosed.
That's the key.
That's the perfect segue. Let's talk about treatment. Because for a long, long time, the treatment for dementia was basically good luck and get your affairs in order.
Or Aricept, which helped, but didn't solve the underlying problem.
Right. Maybe a pill that helped symptoms for a few months, sort of clearing the fog for a bit. But it didn't stop the train. The disease just kept marching on underneath.
We called those symptomatic treatments. They were like turning up the volume on a radio with a dying battery. It helps for a moment, but the battery is still dying. The underlying machinery is still failing.
But the senior techie says, we have entered a new era of drugs. We're talking about monoclonal antibodies. Now, I know that sounds like a mouthful, but these are the drugs ending in mab.
Correct. The two heavy hitters mentioned in the report are lecanemab and donanemab. And the key difference here, the thing listeners really need to grasp, is that these are disease-modifying therapies.
Okay, disease-modifying. Break that down.
They aren't just masking symptoms. They are biologically changing the course of the disease. They're intervening in the process itself.
So how do they work? If they aren't just boosting brain chemicals, what are they actually doing in there?
They are actually immunotherapies. They are antibodies, engineered in a lab, designed to hunt down one specific thing: amyloid plaque.
The gunk.
The sticky protein that builds up between the neurons. These drugs enter the brain, attach themselves to that plaque, and essentially wave a flag that says to the body's immune system, hey, over here, eat this.
So they recruit your own immune system to clear the garbage out.
That's exactly what they do.
That sounds incredible. But does it work? Let's look at lecanemab first. It's been around for a little bit now, approved back in July 2023. But the senior techie has new data on the long-term effects, right?
Yes, and the long-term data is where the hope really solidifies. Originally, the trials showed it slowed cognitive decline by 27%.
Okay, I want to push on that number, 27%. If I'm losing my memory, does slowing it down by a quarter really matter? Is that something I'd actually notice day to day?
That is the big debate in the medical community. Statistical significance versus clinical significance. Is it meaningful in real life?
Exactly.
But the senior techie reports on a 4-year follow-up study that puts this into perspective. They found that 69% of early-stage patients on lecanemab showed improvement or cognitive stability.
Stability. That's the key word there. In the world of Alzheimer's, stability is a victory. Usually, the line on the graph only goes down.
It only goes down. To stay the same is a huge win. And for those with low tau accumulation, meaning they caught it early using those blood tests we just talked about, 64% improved or stayed stable in their daily activities.
Let's make that concrete for people listening.
Yeah.
What does daily activities mean? We're not talking about calculus.
No. We are talking about the difference between being able to dress yourself or needing help with buttons. The difference between making your own lunch or needing someone to feed you.
The difference between staying in your own home
Or moving into care. The difference between continuing your hobby of woodworking or having to give it up because you can't follow the steps.
That is the difference between living independently and needing full-time care. That is massive.
It is. It buys time. It buys quality of life. And then we have donanemab, which was approved in July 2024. The statistics here are even more headline-grabbing.
This is the one that blew my mind when I read the report, the zero decline stat.
It is a powerful finding. The senior techie highlights that 47% of participants treating with donanemab displayed zero cognitive decline after 1 year.
Wait, say that again. 47%. So nearly half the people taking this drug got a full year where the disease essentially paused.
That's what the data showed, compared to 29% on the placebo. So it is a dramatic shift.
What's happening? Why is it so effective?
These drugs are aggressive at clearing the amyloid. Donanemab led to dramatic reductions visible on brain imaging. In many patients, the amyloid levels dropped so low they were technically amyloid negative.
So it cleared the plaque entirely.
It cleared the visible plaque, like power washing the driveway. The gunk was gone.
But, and there is always a but in medicine, you can't just power wash a delicate organ like the brain without some risk. The senior techie is very clear that this isn't magic dust. It's serious medicine with serious side effects.
It is.
We need to talk about the fine print.
We do, and we have to be honest and clear about it. The main safety concern with this class of drugs is something called ARA, amyloid-related imaging abnormalities.
That sounds terrifying. Imaging abnormalities? What is actually happening in the skull?
In plain English, it refers to swelling in the brain. We call that edema, or tiny microbleeds, microhemorrhages.
Why? If the drug is just removing plaque, why does it cause bleeding or swelling? That seems counterintuitive.
This is the nuance. That amyloid plaque isn't just floating around in space. Sometimes it is embedded in the walls of the blood vessels themselves.
Oh, I see.
So when the drug comes in and rips that amyloid out, it can leave the vessel wall a little thin or leaky or inflamed.
Ah, okay. You're pulling the mortar out of the book wall, and the wall gets a little shaky.
That's a perfect analogy. And that shakiness, that leakiness, causes the swelling or the microbleeds.
So how common is this? If I'm taking donanemab, what are my odds of this happening?
The senior techie notes that with donanemab, ARIA occurred in roughly 37% of cases.
37%, that's more than 1 in 3. That sounds really high. If you told me a headache pill had a 1 in 3 chance of making my brain swell, I wouldn't take it.
It is a significant number, and it requires careful monitoring. However, and this is the crucial reassurance that the senior techie provides, 96% of those edema episodes resolved on their own.
They went away.
They resolved radiographically. The swelling went down, usually within roughly 2 months. The report says 58 days to be precise.
And did people feel it? Or was it just something you see on a scan?
And that's the other key point. Most were asymptomatic. The patient didn't even feel it. The doctor just saw it on the routine MRI.
So doctors know when to look for it.
Exactly. It happens mostly during the first 3 infusions. So the protocol is, you take the drug, you get regular MRIs during that initial period. If the doctor sees the swelling, they pause the medication, they let the brain heal, then they decide if it's safe to restart.
So it transforms a scary risk into a managed risk.
That's the perfect phrase for it. It's a known quantity.
That context is so important. It's not take this and hope for the best. It's take this and we will watch you like a hawk for the first few months to make sure you're safe.
Precisely. And when you weigh that temporary manageable risk against the certainty of progressive cognitive decline without treatment, many seniors and their families are deciding the benefit is worth it.
Okay, so we have blood tests to find it. We have drugs to slow it down or even pause it. But here is where it gets really interesting to me. This senior techie points out a statistic that literally made me drop my jaw. The oops factor.
Yeah, the misdiagnosis rate. It's shocking.
The senior techie reveals that up to 13% of dementia diagnoses are actually misdiagnosed treatable conditions.
Think about that for a second. More than 1 in 10 people who are told, I'm sorry you have dementia and it's irreversible, actually have something else entirely.
Something fixable?
Something potentially fixable, yes.
That is tragic if you don't catch it, but incredibly hopeful if you do. What are these conditions? What mimics dementia so perfectly that it fools doctors?
One of the most common culprits mentioned in the report is hepatic encephalopathy.
Hepatic? That's liver, right?
Yes, it is a liver issue affecting the brain.
Hold on, I thought we were talking about the brain. How does the liver get involved in a brain problem?
The body is one big interconnected system. Your liver is your body's primary filter. It cleans the blood of toxins.
Okay.
If the liver is struggling, maybe due to undiagnosed cirrhosis, fatty liver disease, or other metabolic issues, it stops filtering out toxins effectively. One major one is ammonia.
And those toxins don't just stay in the liver, they get into the bloodstream.
They do not. They circulate in the blood, cross that blood-brain barrier we talked about, and enter the brain. And ammonia is highly neurotoxic. It disrupts the way neurons fire.
So the symptoms. What would I see?
The symptoms: tremors, hallucinations, severe memory deficits, gait instability, confusion, can look exactly like dementia. To an observer and even to a doctor without the right tests, it fits the pattern of Alzheimer's or Lewy body dementia perfectly.
So you have a person who is confused, shaking, maybe seeing things, and everyone assumes it's their brain degenerating, but really it's the liver just needing help.
It could be. And the cure in this case is simply treating the underlying liver or metabolic issue. The senior techie notes that doing so can cause dramatic symptom reversal.
Reversal, that's a word we rarely get to hear in this field.
Almost never. But patients can go from a state of severe cognitive impairment back to near normal functioning once the toxins are cleared from their system. It's remarkable.
This brings up the tech angle. How are we getting better at spotting this? Because obviously humans are missing it 13% of the time.
Machine learning is stepping in. AI. The senior techie reports that new AI models are reducing diagnostic error rates by up to 84% in this specific area.
What is the AI seeing that the doctor isn't?
It is seeing nonlinear correlations. A doctor looks at a chart and checks boxes. Liver enzymes look okay-ish, memory is bad, must be Alzheimer's.
Right. Pattern recognition.
The AI looks at the full complexity, the slight elevation in ammonia, the specific pattern of the gait, the history of medication, blood pressure fluctuations, and it flags subtle patterns that a human brain might miss. It can say, hey, wait a minute, the probability of this being metabolic is 80%. Have you checked X, Y, and Z?
So here is the actionable advice for our listeners. This is so important. If you or a loved one gets a dementia diagnosis, or if you have had one for a while, what should you ask?
You should explicitly ask your doctor, have we ruled out metabolic causes like hepatic encephalopathy? Have we done full metabolic panel and checked the liver function?
It's a simple question.
It is. And for 13% of people, it could change everything.
That is worth the price of admission right there. Just asking that one question.
Absolutely.
All right, let's pivot. We've talked about high-tech blood tests and powerful new drugs, but I know a lot of our listeners are thinking, I don't want to take drugs if I don't have to, or maybe, what can I do right now, today, in my own living room to protect my brain?
And that is where the finger model comes in. This is the empowerment piece of the puzzle.
The finger model. It sounds like something from a spy movie, but it stands for the Finnish Geriatric Intervention Study, right?
That's the one. It is the gold standard for lifestyle research. And the headline from the senior techie here is that lifestyle is medicine. But it's not just one thing. It's a specific combination of things done together.
There are 5 domains, I think.
Correct. The 5 fingers: physical activity, cognitive training, nutrition, cardiovascular monitoring, and social engagement.
Let's break down the big ones. Exercise, we all know we should do it, eat your veggies and go for a walk. But how much does it actually help the brain? according to the data?
The senior techie is very specific here. Physical activity alone reduces the risk of cognitive decline by 50%.
50%. Half, just by moving.
If done correctly. The protocol is 30 minutes of moderate activity, 2 to 3 times weekly.
That's it. That's not training for a marathon. That's a brisk walk, a dance class, a swim, gardening.
It is very, very achievable for most people, and the bonus is that it reduces multimorbidity, which is the fancy term for having multiple illnesses at once, by 60%. So you are protecting your brain and your body at the same time.
But here is the nuance that I found really fascinating in the report. It's not just about doing the crossword puzzle alone at the kitchen table.
No. And this is the secret sauce that the senior techie really emphasizes. Socializing.
We tend to think of socializing as just fun, not medicine.
We are social animals. Our brains are wired to interact. The finger study found that doing these interventions together works better. Social engagement improves adherence.
Meaning you're more likely to stick with it.
Exactly. You're more likely to go for that walk if you're meeting a friend. But it also does something to the brain itself. It's not just about motivation.
There was a stat about computerized training. Brain games on a computer.
Yes. Doing brain games alone at home is okay. It helps a little. But doing them in a group with a supervisor or a coach is significantly better.
How much better?
The statistic was a 0.72 improvement for supervised verbal memory versus a much lower score for unsupervised. It's a big difference.
Why? Why does having someone else in the room make my memory better?
Because it creates multiplicative benefits. When you are in a group, you have social learning, you have friendly competition, you have emotional support, you are reading facial expressions, you are navigating conversation, you're explaining your strategy. All of that is extra work for the brain. It builds cognitive reserve.
Cognitive reserve. I love that term. It's like a savings account for your brain, right?
Exactly. If you have a deep reserve, a dense network of connections, even if you have some pathology in your brain, even if you have some plaque building up, you might not show symptoms because you have so many backup connections, so many workarounds.
The brain can reroute the traffic.
It can, and socializing builds those new roads.
So the takeaway is, don't just walk. Walk with a neighbor. Don't just do Sudoku. Join a bridge club or a book club.
Connect. It is as powerful as the exercise itself. The report makes it clear that isolation is essentially toxic to the aging brain. It raises cortisol, the stress hormone, which actually shrinks the hippocampus, the memory center. So by socializing, you are literally lowering stress and building new connections.
Now, I want to get a little sci-fi for a minute, because the senior techie report goes into some really advanced, almost futuristic stuff regarding how we get drugs into the brain. We touched on the blood-brain barrier earlier.
This has always been the fortress we couldn't breach. The bouncer at the club who says, "You're not on the list."
The very strict bouncer.
Its job is to keep toxins and viruses out of the brain, which is good, but it also keeps about 98% of potential medicines out.
But the senior techie discusses a 2025 Wake Forest study that found a back door.
A secret entrance.
The nose.
A nose. Intranasal insulin.
Sniffing insulin. Now, why insulin? I associate insulin with diabetes and blood sugar, not memory.
Well, the brain is an energy hog. It accounts for only about 2% of your body weight, but uses 20% of your body's energy, mostly in the form of glucose.
That's the gas guzzler.
It absolutely is. And insulin is the key that unlocks the cells to let the fuel, the glucose, in. In Alzheimer's, the brain becomes insulin resistant. It starts starving for energy.
So it's like a city in a blackout.
That's a great way to put it. We sometimes even call Alzheimer's type 3 diabetes. The brain is starving even if the body is fed.
So why not just inject insulin?
Because if you inject insulin into the arm, it drops your blood sugar everywhere in your body, which is very dangerous if you aren't diabetic. It can cause a coma.
So how does the nose help? How does it solve that problem?
By using a specially designed nasal spray, they can send insulin directly up the olfactory nerve to the hippocampus, the memory center of the brain. It bypasses the bloodstream entirely.
So no shots, no low blood sugar crash,
Yeah.
and it goes right to where it's needed.
Correct. And because it bypasses the rest of the body, you can use a much smaller dose and reduce the systemic side effects to almost zero.
But there was a catch about how people absorb it, wasn't there?
Yes, and this goes back to the idea of personalization. This study found that people with cognitive impairment absorb it differently than healthy people. They have a very rapid uptake, but also a very quick clearance.
So it goes in fast and it leaves fast.
Which suggests that dosing needs to be personalized. One puff twice a day might work for you, but I might need a different dose or a different schedule. But the fact that we can target the hippocampus through the nose is a delivery revolution.
And briefly, the report mentioned even wilder stuff, nanotech, exosomes.
Oh yes, this is the next frontier. They are looking at exosomes, which are like tiny biological envelopes or Trojan horses.
Trojan horses.
You hide the medicine inside a natural biological particle so the body doesn't reject it, and it sneaks past the defenses, past the bouncer. There's also research into using gene therapies like CRISPR-Cas9 to go in and edit the genes that produce these toxic proteins. It's still in development, but it's on the horizon.
It's incredible. It really feels like we're throwing the kitchen sink at this problem. But the sink is full of high-tech gadgets.
We are attacking it from every conceivable angle: diagnosis, clearance of proteins, lifestyle changes, and now these advanced delivery systems.
Let's talk about another angle, the immune system of the brain itself. I didn't even know the brain had its own dedicated immune system.
It does. They are called microglia.
Microglia. Sounds small.
They are small cells, but they have a huge job. Think of them as the janitors and the security guards of the brain all rolled into one.
They clean up the mess.
They sweep up debris, dead cells, waste products. They keep the environment clean. But in Alzheimer's, something goes wrong. The janitors get confused and angry. They go haywire.
What do you mean haywire?
Instead of just sweeping the floor, they start attacking the furniture. They become pro-inflammatory. They see the amyloid plaques and they overreact, causing chronic inflammation that damages healthy neurons.
Neuroinflammation. That sounds destructive.
It is a major driver of the disease. And for a long time, we just tried to suppress them. We thought inflammation is bad. Let's just shut down the microglia with anti-inflammatory drugs.
But if you fire the janitor, the trash piles up.
Exactly. So you can't just stop the inflammation entirely. You need them to do their job, but you need them to do it correctly. The new drugs, like one called ALZT-OP1, mentioned by the senior techie, don't just stop inflammation. They regulate the cells.
So it's management, not suppression. It's more nuanced.
Much more. They essentially calm the janitors down and tell them, hey, start breaking the furniture, just go back to sweeping up the trash. It shifts them from an inflammatory state to a repair state.
That is such a sophisticated approach. It's not just anti-inflammatory, it's smart regulation.
And this connects to another acronym in the report that I think is really important for people to know about, BDNF.
Brain-derived neurotrophic factor.
A mouthful, I know.
I call it miracle grow for the brain.
That is the perfect analogy. It's brain fertilizer. BDNF is a protein that supports the survival of existing neurons and encourages the growth of new ones. It helps with synaptic plasticity, the ability of your brain cells to talk to each other more efficiently.
And Senior Techie says high levels of this stuff protect against dementia.
It creates resilience. A brain rich in BDNF is a healthier, more connected brain. And here is the beautiful connection to what we talked about earlier. How do you get more BDNF?
I'm guessing it's not a pill you can buy at the gas station.
Not yet. You get it through exercise and cognitive training. Remember the finger model. When you exercise, your muscles secrete proteins that travel to the brain and trigger the release of BDNF.
So that's the mechanism. That's why it works.
That is the biological reason why the lifestyle changes work. You are literally manufacturing your own brain fertilizer every time you go for a walk.
So when I go for that 30-minute walk with my neighbor, I am pumping Miracle Grow into my hippocampus and building my cognitive reserve at the same time.
You are. And combining that with learning something new, cognitive training, is like planting seeds in that freshly fertilized soil.
I love that image.
Yeah.
It makes the advice feel so much more actionable. It's not just, it's good for you. It's, this is the mechanism inside your skull.
Understanding the why always helps with the do.
We have to talk about the economics of this. And I don't mean stock prices. I mean the value of time and the value to society. The Senior Techie brings up this huge concept of the preclinical shift.
This is the economic and societal argument for everything we have discussed so far. The wait-and-see era is over because we now know without a doubt that the damage happens 10 to 15 years before you forget your Ps.
10 to 15 years. So if you get diagnosed at 75, the process probably started when you were 60.
Correct. Or even 55. So waiting for symptoms is waiting until the house is already half burned down. The goal now is to treat the preclinical stage before the fire is out of control.
And the value of doing that is staggering. The numbers are just mind-boggling.
They are hard to wrap your head around. The Senior Techie reports that treating just 2 years earlier, moving the average diagnosis from age 73 to age 71 as $1.9 trillion in societal value.
Trillion with a T.
And if we treat pre-symptomatically, Before any symptoms show up at all, that value jumps to $3.9 trillion.
And that's not just dollars. That represents cost savings in care, sure, but also it's life, it's productivity, it's grandma being able to watch the grandkids, it's people staying their careers longer.
It is the value of human capital and quality of life. And crucially, it relieves the immense burden on caregivers, who are often family members sacrificing their own careers and their own health to provide care.
And this all loops back to the beginning. Because of the blood tests we mentioned at the start, we can now find these asymptomatic people.
Right. Before, you couldn't recruit people for preclinical trials because you didn't know who had the pathology until they were already sick. Now you can find the people who are 10 years away from symptoms and potentially help them today.
It's the golden age of recruitment.
It is. It removes that bottleneck and accelerates every other piece of research because we can finally test drugs on people who haven't suffered irreversible damage yet.
And finally, before we wrap up, we have to touch on quality of life. Because even with all this incredible science, people are living with this condition right now.
And the senior techie emphasizes that it is not just about curing, it is about living well with the diagnosis. We are seeing the rise of things like memory cafes.
Memory cafes. Tell me about that.
These are safe, welcoming spaces where people with dementia and their caregivers can go to socialize without fear of judgment or stigma. It combats that isolation we talked about. It's a place to just be yourself.
And technology helps too, right?
Absolutely. Technology-enabled stimulation, apps and devices designed specifically for cognitive impairment, and the CMS Guide model.
Guide. What's that?
It is a new care model from Medicare focusing on dementia care management. It provides a budget for comprehensive care coordination, caregiver support, and importantly, respite care.
So help for the caregiver to get a break.
Which is so critical to preventing burnout. The whole model is focused on keeping seniors in their homes and maintaining their independence for as long as possible.
The goal isn't just to extend life, but to extend the quality of that life, to ensure that the years we add are good years.
Precisely.
So let's bring it all home. We have covered a lot of ground in this podcast.
We have. It's a lot of hopeful information.
If I had to summarize the entire report from the senior techie, it's this. We have better tests, the simple blood tests that make diagnosis accessible and painless. We have better drugs, the antibodies like donanemab that actually clear the plaque.
We have a better understanding of lifestyle, the finger model, the power of social engagement, and the biology of BDNF.
And we have better delivery systems like nasal sprays on the horizon.
It is a convergence. There's no single silver bullet, but it's like a silver buckshot. A lot of solutions working together from different angles.
And here's the provocative thought I want to leave you with, something to mull over. We might be approaching a time where Alzheimer's is managed just like diabetes.
That is a powerful comparison.
Think about it. A century ago, a type 1 diabetes diagnosis was a death sentence. Now, you get a blood test. You catch it early. You manage it with medication and lifestyle changes. You watch your diet. You exercise. And you live a full, long life.
You don't die of it. You live with it.
The fear is replaced by management.
Exactly. And that's the shift we're seeing here.
We are moving from the era of fear to the era of management. And that, to me, is the most hopeful thing I've heard in years.
I agree completely. It is a wonderful time to be following this science.
This podcast was brought to you by The Senior Techie. It's available on Apple Podcasts, YouTube, and Spotify. If you'd like to keep up with their newsletters, you can subscribe for free by going to theseniortechie.com.
Thanks for listening.